Welcome to another video about metal roofing. Today I'm joined by Jeff Haddock, our Technical Services Manager, and we're talking about metal roofing clips. So a few of our metal roofing products use clips. So Jeff, tell us, what is the purpose of a clip in a metal roofing system?
The purpose of clips are always going to be intended for concealed fastener profiles, and that covers a wide range. We have a pretty wide offer because we do standing seam profiles, which is a concealed fastener profile. Well, you've got to have some way of attaching that if you're not going to have any type of exposed fasteners. And the clips are there to allow for that concealed attachment. But clips are not just subjected to be used with standing seam profiles. We also have concealed fasten wall panel applications as well, where the wall panels may also utilize a clip for their attachment to a given substrate.
And so these clips on roofing, though, it's not just as a form of attachment to the structure. It also serves other purposes as well, too, right?
Absolutely. Clips are there to do two things. They're there to resist wind uplift loads. So in essence, we put a particular, if we did the engineering package for you, or if you utilize any of our engineering reports for our panels, we have specific clip spacings for all of our concealed fasten profiles that give you a pounds per square foot of wind uplift load resistance based off of whatever substrate you might be attaching it to, plywood, open framing, metal deck. There's a whole myriad of types of substrates that can be attached to. And we'll have a set specific spacing that needs to be adhered to meet whatever that wind load resistance is. So that's preventing that clip or that clip preventing that panel from ripping off and being blown off of the roof during a wind load event. The other part of what clips do and what they're designed intentionally to do is to allow for thermal movement. And that's the expansion and contraction of the metal when it's heated and cooled. So all metal, regardless of the type, expands and contracts, expands when heated, contracts when cooled. Now, the rates of that thermal movement can differ based off of the material, whereas with steel, you're going to have a less thermal movement than you will with an aluminum panel. But you still must account for this thermal movement. And what these clips are designed to do is to allow for that panel to expand and contract freely, thus not ripping itself apart, buckling, things of that nature to allow that panel to expand and contract. Now, a good rule that we use for expansion contraction rates on steel, you can usually account for about plus or minus 1/8 of an inch per 10-foot of panel run of thermal movement. So if you're looking at a 30-foot panel run, you can account for roughly about 3/8 of an inch of thermal movement. The longer the roof, the more thermal movement that's going to take place. Now, by comparison, an aluminum profile has twice the rate of thermal movement that steel does.
Wow.
So where you would be dealing with 1/8 of an inch per 10-foot of panel run, with steel, on an aluminum panel, you're dealing with 1/4 of an inch plus or minus per 10-foot of run. So having the appropriate clips and allowing for thermal movement as well as resisting wind uplift is a very critical aspect of what clip design and making sure you're using the proper clip and proper clip spacing.
And so I know some panels have a couple of different clips to choose from. What are generally the different clip types that we offer with different products?
We have different clips for different roof systems. We have different clip heights that allow for venting spaces under the panel. Or compression zones where we may need to compress insulation over a purlin with bat style insulation. We have floating clips which allow for thermal movement. We have fixed clips which lock the panel in certain locations for, say, if we're doing a really long run, and we have certain clips that only allow for a certain amount of thermal movement, specifically in our mechanically seamed profiles. Let's say our mechanically seamed profiles only allow for plus or minus 1 inch of thermal movement, right? Well, that limits you to about a 75 to 80-foot roof run. Well, what if your roof is 100 feet or 120 feet or 150 feet? What we can do is we can actually utilize fixed clips in the center of a roof run, which lock the thermal movement, and then we can actually expand and contract the roof uphill, and we can expand and contract the roof downhill. And the flexibility of having different clips is we can tell the expansion contraction what we want it to do. We can't get rid of it. We must account for it, but we can shift it in certain directions and play with it and have it push uphill or have it push downhill and allow us to get longer roof runs specifically with our mechanically seamed panels. The other types of clips are our single piece clips. Those are intended to be used with our snap lock style panels or our batten seam style panels. And those clips, the thermal movement actually takes place within the clip, with the panel actually expanding, contracting within the clip itself. These types of clips offer unlimited thermal movement. So what that allows is it allows us to get very long lengths with our snap seam and batten seam style panels, because you're not restricted by the thermal movement within the clip. And I actually have another video that we've published that really delves into this subject, and I would encourage anybody to take a look at that on our AEP Spans YouTube page for designing around thermal movement, where I really delve into this subject matter that gives you really good visuals and graphics.
Yeah, that's a great resource, and I think it can also be found on our Learning Center. So I know too, Jeff, you spend a lot of time up on roofs looking at installation. So what are the things that you commonly see go wrong with clips, or things that, maybe catch contractors out in the field?
The biggest problem with the clips that I find, incorrect spacing. That's a big one. Obviously, we want to make sure we're adhering to whatever engineering we need on that, or the incorrect fasteners being used. That's a big thing. So like the clips do require a fastener through the clip into the substrate. Well, if you're not using the correct fastener for that, and you may have the correct spacing, it's really all for naught at that point, because the fasteners could potentially rip out of that substrate. So we want to make sure we're using proper spacing and proper fastener selection when attaching those clips. And that could be the size of the fastener that's needed, the type of drill point or non-drill point that may be needed on the fastener length that might need to be extended because you're going through various layers until you actually hit a solid deck. So those are some of the biggest concerns that we have on that.
Fantastic. All right, some good learnings on clips there, Jeff. And yeah, as we talked about, we've got a lot more about that topic of thermal movement in our Learning Center, so be sure to check it out.